next we are going to look at the float or level switch, how they are represented in the electrical circuitry. So we are also going to see briefly how these float switch they operate, what they look like, and how they are connected in the physical circuitry. So if you look at your screen now, you will see how the float switch is represented in the circuitry. So this is the float switch symbology. The first one is for the normally closed, normally open float switch. Okay, so you see the float or the ball, okay, that is attached to a contact. The first one is activated to close, and the second one is activated to open. So this is how the float switch look like, okay, on the ground. So you see the float with wires attached to the end of the float. So the connection wires, okay, they are here, and this one runs from the tank to the control circuitry. So this is the float switch that is open. So if you look inside, you will see a metal ball. So as the float switch drop to become vertical, the metal ball will roll down, and as you can see, that lever, okay, this lever that is connected to this switch will now be activated by that metal ball. So the switch will either be made to close or open, and depends on how you configure it, to either start your pump motor or to start other process, or stop your pump motor or stop other process. Okay, so that is the metal ball. Then this is when it has come vertical. So when the level of the fluid, that is the liquid in the tank, okay, rises, the float will now become vertical. That ball will drop, and once that ball drops, it will free that lever and deactivate the switch. Okay, so it depends on which terminal you are using. If it is a normally closed terminal, then the deactivation will make it to close, okay, because it is normally closed. Then if it is normally open, okay, the deactivation will make it to open. So this is how it is connected physically, okay. So you see the float switch in the tank. See the float switch in the tank, and it is installed to help us maintain a definite level of liquid in that particular tank. So with this kind of arrangement, the liquid in the tank will not fall below that level. When it falls to that level, you see the way the float switch is standing vertical, the ball will have dropped, and as the ball drops, it will either make or break the circuit. Okay, depends on the configuration. And then if that happens, it depends on your configuration too. It can start or stop your pump motor. But let's assume that we need to fill, once it drops to this level, we need to fill the tank again. So this means that as it drops to that level, the switch will close, and it will close the supply circuit to that contactor coil, and the contactor coil, and then the contactor will be energized, it will close, and then that will send power to the pump motor, and then the pump motor will start, the pump will start filling the tank. So if you look at it, you see from the power source, okay, this is the energy meter. Then from there you have the circuit breaker. Okay, so from the circuit breaker we have the contactor. Then one end, the lifeline is attached to one end of the contactor coil. Then the neutral, which is the line that is broken. In this case, one end is attached to one terminal of the float switch, and then that terminal is attached to the other end of the contactor coil. So once the float switch is closed now, you will see now that the circuit will now be closed to the contactor coil, and the contactor coil will be energized. And once it's energized, the contactor will close and close power to your motor. Okay. Then as it is rising up, it will rise to a level. The ball will now roll off that arm as earlier depicted, and once it rolls off that arm, the switch will be deactivated, and then the pump motor will stop, because the contactor coil, in this case, will now have power broken to it, and it will drop, it will be deactivated, and then the motor will stop. So that is how it is connected, the float switch. So let us look at the pressure switch next. So at times we may need to monitor the pressure and interface what is being monitored with the operations of our electrical circuitry. So these pressure switches or switch, how are they represented in the electrical circuit? If you look at what you have on your diagram now, you see how pressure switches are represented. So we have the normally open contact, the one up, and then we have the normally closed. So the normally open is activated to close, while the normally closed is activated to open. So here is Kali. Okay, so at one end you see the orifice to which the impulse line from your process is attached. Okay, so the pressure in your process is sensed at that orifice. There is something like either a strain gauge or a diaphragm that helps to sense the pressure. Okay, so as the pressure sensing devices moves, you will see that it can either make or break a contact within that switch. So if it makes the contact, then if it is connected to a pilot light, it will indicate to us that that particular pressure level that we set it at has reached. So if there is any action to be taken in the operational processes, then we need to take those actions to either bring the pressure down or to maintain the pressure at that level, not to allow it to go beyond that level. Or we can also configure it to control other processes. Okay, maybe to initiate the use of such compressed air or compressed fluid in another process. So once that pressure level, it gets to that pressure level, that other process will be initiated to start operations. So this is how it is connected physically. So this is a small compressor with a small pressure vessel. So as the compressor motor is energized, it will definitely start working. It will run the compressor, compresses the air, and send the air into the vessel. So as the vessel is pressurized, it will pressurize to a level. This pressure switch will be activated. Okay, so once it is activated, assuming it's activated to close, it will now close this power line, okay, that comes from this miniature circuit breaker to the contactor coil at A1. Okay, so if you look at it, you see that the neutral is already connected directly to the other terminal of the contactor coil at A2. So A1, once it is close at the pressure switch, the circuit will now be completed, okay, and the contactor coil will be energized. The contactor will close and power will run from the input of the contactor to the output and then to your compressor motor, okay. That is to activate. The if it is to deactivate, of course this switch, once it opens up, it will deactivate the contactor coil. The contactor will open, okay. So once it opens up, of course power will be lost to the compressor motor, and thus the compressor will stop, and then the pressure will stop building up. And then as you are using the pressurized gas in the tank, the pressure will be dropping. It will drop to a level the contact will make again, and the compressor motor will come on and pressurize the tank. So this is how it is connected physically, okay. In some cases, like in this case now, we are looking at the pressure in this vessel. So we can also look at the pressure on the line. So next, we are going to look at the temperature switch. Temperature switch, its function is to look at the temperature of a process and then either close or open a contact, okay. Depending on what we want and the configuration, it will either initiate another process or stop that particular process that we are looking at. So this is how it is represented. You see the thermal element connected to the switch. So on the left, we are on this particular one is normally open. So which means that this one, when activated, it closes. Okay. So the activation is done by the movement of that thermal element. So this is the physical temperature switch. So if you look at it, this front end of it, we have the thermal sensing element, which could be, most likely be a bimetallic strip. So that bimetallic strip, as we know, they are made of dissimilar metals. So these dissimilar metals, they are joined together. Since their rate of conducting heat is different, they are bound to bend. The combination of them is bound to bend to a particular direction. So as it's bending, it will either make or open a circuit. Okay. So once that circuit opens, that means it is the configuration is activation to open. Okay. But if the bending will cause the closing of a particular contact, then the configuration is activation to do what? To close. So this is the physical representation, how you see it on ground. We have the thermal element here. These are the two contacts where you connect your cable to. Okay. So this is another type. You have the sensing element here that you attach to your process to look at the temperature of your process. Then this is a junction box, okay, where you can terminate your control cable to your control circuitry, okay, in your process. So this is how they are represented. One is normally closed and the other is normally open thermal switch. So next we are going to look at this is how it could be wired or installed physically. Okay, remember we looked at this circuitry when we were considering pressure switch. That pressure switch could also be a temperature switch. Okay, we know that as you are compressing the air, the temperature of the compressed air or gas definitely will go up. So it will go up to a stage that the switch that we are seeing will close, okay, or open, as the case may be. So assuming that we want it to open when the temperature goes to a particular level. So once it opens up, the contactor coil will be de-energized, and that will disrupt or break the power that is flowing to the compressor motor. And as the compressor is no longer compressing, you see that the heat in the vessel will stop building up. Okay, so it can be configured when it drops to a level, the switch will close, contactor coil will have the necessary signal, it will be energized, and that will close the contactor supply to the compressor motor, and then it starts compressing again. Okay, and then the cycle will repeat it.